As requested, here are the problems from the Adding Vectors worksheet that we did in class today. Number 1, "30 meters east plus 20 meters east equals 50 meters east." Number 2, 2,000 miles west plus 1,000 miles east equals 1,000 miles west, because west is the bigger number here. Number 3, 7 meters per second up, 3 meters per second to the right. Notice that I drew this first vector, and then immediately at the ending point of the first vector, I started my second vector. All right, how do you add these? You have to find the length of this line. If I add these two vectors that are perpendicular to each other, then my resultant, or my result, is this line right here. So I need to figure out how big that is. So I'm going to square 3 plus 7 squared equals c squared, c being my hypotenuse right here. So if you put that in your calculator, you should get root 58 is equal to c. Number 4. "4 meters per second up and 4 meters per second to the left." Alright, this angle should be 45 degrees because I have two legs that are the same side, and if that's the case, then these angles are going to be congruent. But let's do the math. Oh, actually never mind, sorry guys, we're not trying to solve for angles, we're trying to solve for length. So what's the length of this side of this vector? Same thing as the last problem, we're going to do the Pythagorean theorem, which says that the sum of the square of the sides is equal to the square of the hypotenuse. Or also a squared plus b squared equals c squared. So my a and my b are 4, so I square those and add them together. I get 32 is equal to c squared. So c is equal to root 32. Okay. First problem on the back, number 1. I think I did this example in class, but I'll go ahead and do it again. I have a vector called vector f, and vector f is 45 meters long at 75 degrees. Okay, how do I do that? First thing that I need to do is draw a picture. So there's my picture. It's my XY axis. And around the axis, I'm labeling the degrees as we have assigned them. So it's just the rule that we always follow, that our angle starts from the positive x axis and then goes up this way. Here's 90, 180, 270, and then back to 0, or you could think of it as 360 as well. So where is 75 degrees going to be here? Well, it's going to be somewhere in between 0 and 90. It's going to be a little bit closer to 90. So I'm going to draw it like this. So the length of it is 45. The angle is 75 degrees. So now I want to find the components of this vector. I can break this vector down into its x and y components. That's the length that the vector runs in the x direction plus the length the vector runs in the y direction. You could think of it as doing what we had just done on the front, right, but backwards. In this case, I gave you 2 legs and I wanted you to find this length. Here, I'm giving you the hypotenuse and an angle, and then I want you to find these 2 lengths. And you do that using the formula that I gave you guys. The formula says that Vx equals, that the x component of V is equal to V, the magnitude of V I should say, times the cosine of my angle theta. And then if I want to find the y component, I multiply the magnitude of my vector times the sine of my angle theta. So I'm not going to plug these into the calculator, but I will write down what I would plug into the calculator. So if I was trying to solve for this component right here, the x component of this vector, I would plug in 45 times the cosine of 75. And this is just, this cosine of 75 here, that's just a number that you can plug into your calculator, just like 45 is. Don't let the cosine throw you off and think it's more complicated than it is. You just plug this straight into your calculator, and your calculator will do the work for you. So if I want to find my y component, that's this right here, then I use this formula. Okay, number 2. I have a vector V, and vector V has a magnitude of 6 meters per second and a direction of 200 degrees. So I start drawing my picture, as always. 0, here's 90, here's 180, here's 270. Okay, where is my 200 gonna be? Is it in between 0 and 90? Nope. Not here either. It's gonna be between 180 and 270. Probably closer to 180 than to 270. So I put my pin in the middle at the origin, and then I want to draw a line that makes a 200-degree angle with this line right here. And that is approximately it. So how long is my vector? It's 6 meters per second. Now I need to find my x and y components again, right? So for this vector, I expect for my x component to be negative because it runs in the negative x direction. I also expect for my y component to be negative because my vector runs in the negative y direction. So again, I'll just write out what I would plug into my calculator. If you guys need to pause right now or rewind just to think about it, go ahead. But that's all I'm going to say about that problem. Okay, number 3. Oh, this is a tricky one. Tricky. So, let me go ahead and start by drawing my XY axis. And if I label this 0, 90, 180, and 270, where's 90 degrees on here? 90 degrees is straight up. So if I want to draw the line 8 units at 90 degrees, well, I'm going to start the way that I did over here. Start with my pen in the very middle at the origin. And then I would just draw a line straight up like this. And you can label it 8 meters per second squared. What is my x component of this vector? Well, we could put it in the formula. And if you put that in your calculator, you're going to get an answer of 0. Because this vector doesn't run any in the x direction. Neither positive nor negative. It just runs straight up in the y direction. And if you put this in your calculator, you're going to get 8. The entire magnitude of this vector runs in the y direction. None of it runs in the x direction. So that is that problem. I don't have much room to finish number 4, and my computer's running out of battery. So you guys could do number 4 on your own, but that should be good review for your quiz tomorrow.